Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 11.2, surface area of geometric solids. So first, what is surface area? Surface area is simply finding the area of all faces of an object. So, example 1. We have a wooden cube. It has side lengths of 5 centimeters, and we're going to find the surface area. That means I don't want the area of just the front square. I don't want the area of just the right, or the top, or the back, or the bottom, or the left. I want all faces, all surfaces, and then add them together. So, first, says it's got side lengths of 5 centimeters, and since it's a cube, all sides are the same. So, the length is going to be 5 centimeters, the width is going to be 5 centimeters, and the height is going to be 5 centimeters. And that should be a height, yes. All right. So this length, width, and height is just of the object as a whole. Now, there's different approaches you can take to finding the surface area, or the area of all the surfaces. Guarantee you, you're more likely going to have better success if you start with a net. A net is simply an unfolded version of your solid object. So, this is a standard net. It consists of 4 squares long ways, and then 2 squares on top and bottom. So, what does this net show? I have a little cutout here. This top one, if I fold it down, that's going to become the top of the cube. This one over here folds inwards, that's the left. And then this one folds upwards to become the bottom. And then these two over here fold up and then around. So you'd have the front of your cube. So again, your net is just the unfolded version. That way you can see all of the surfaces, find the area of all the surfaces, and then add them together. Okay, so this also has a pretty standard setup or labeling process. So I want these numbers on here. For a cube, that's going to be easy, but we're going to practice. This right here is going to be your length, because if I fold that downwards, that distance long ways in front of me would be my length right there. This is going to be my width, because if I fold that inwards, that distance coming forward is my width. And then it's going to alternate to the length. So this one right on the right, that's going to wrap around, and that's going to be my length again. So you're always going to have that alternating pattern, and this one will be the width. So typically start with the one that's jutting upwards, that's your length, and then it alternates length, width, and so forth. Now, one thing to note, what is this distance right here? When I close those in, it's going to be the same. They have to connect. So that means this is also my width. All right, one more thing, my height. That's technically the distance between the top and the bottom. So that would be this distance from here to here. And again, it's going to be the same all the way across. One more thing, down here, what would this one be? Well, the top and bottom of your prism is going to be identical. But if this is my length, that number is going to be the same, that number is going to be the same, and that number is going to be the same. What would these numbers right here be? Well, if this is my width, I would use the same number right here, and those are going to snap shut or connect, so they have to be the same distance as well. So width. Now, what use is this? It just tells you how to put your numbers on here. And again, we're using an easy example with a cube. All the numbers are going to be 5, no matter what. So you might be like, well, this is pointless. We're just practicing right now. So I want the numbers from my solid object onto the net so I can find the area of them. Because some people, they're not good with spatial reasoning. They can't find the area of the back if they can't see it, for example. Okay, so my lengths are all going to be 5. So I'm going to replace all my L's with 5s. Next, my width of this object is 5 as well. So I'm going to replace all my W's with 5. And last, the height of my object, or cube, is also 5. So I'm going to replace all the heights with 5. And now what do I do? Well, I have enough information to find the area of each individual square, and then I would add them up. So it doesn't matter where you start. I'm going to start finding the area of this square right over here. So formula for area of a square is A equals LW, length times width. So A equals, now don't be confused by the fact that I have an L and an H. You're just looking at the square. What's this side? What's this side? Well, it's 5 by 5. So length is 5, width is 5. Those L's and H's were just there so I can get the numbers from the solid object onto my net. Okay, area equals, what is 5 times 5? Well, that is 25. Now, typically, you would then find the area of each individual other piece before adding them together. But a characteristic of cubes is that they're made up of 6 identical squares. So there is a shortcut. What is my shortcut? It is to take the area of one face, one square, and multiply it by how many there are, because they're all the same. They're all 25. So I'm going to do 25 times 6 faces. And I can do that because they're all equal. If they're not all equal, don't do it. So 25 times 6 is 150. So what is 150? 150 represents the area of all 6 surfaces of that cube. The top, bottom, right, left, back, front. So let's answer it. The surface area is 150 centimeters squared. I am finding area, and area is all about how many squares will cover a surface. So what did we do again? First step, we drew a net, the unfolded version. We labeled our net with our numbers or dimensions, and then we found the area of all of those surfaces, and then we essentially added them together. On this one, we did a shortcut and multiplied by 6 because there are 6 equal sized squares. Okay, let's apply that to another example. So now we're going to find the surface area of a fluffy dice ball with side lengths of 4 inches. So let's pretend we have our fluffy dice ball. Usually hang them from your mirror in your car. So there's our fluffy dice ball. And it says it's got side lengths of 4 inches. So the length is 4, the width is 4, and the height is 4. First step, draw a net to represent that shape but unfolded. So this part that goes upwards, that's going to be my length, and then it's going to alternate width, length, and then opposite direction, width, and then these are all my heights, all the way from there to there. Now I'm going to use that and transfer my numbers to the appropriate spot. So my length are 4. So I'm going to replace all the lengths with 4. Again, the purpose of this is just to get the numbers from here to there. This tells me where they go, because you're not going to always have a cube. With cubes, it's easy. You can't mess up. 4 is going to go everywhere. Okay, width is 4. And don't forget, those two pieces are going to snap shut. So they have to be the same distance. So if this is 4, that's also considered my width, which is 4. I don't need to label this one down here. Why? Because it's going to be the same as the opposite side. Your opposite sides of your prisms will be identical on cubes, that is. Okay, last one, heights. All my heights are 4. Okay, everything is labeled. Now I can find the area of each one if I wish to. For this one, we only need to do one of them because they're all the same. So let's find the area of this square right here. So area equals length times width. Area equals, again, don't be confused by the fact that you have an L and an H. This is still your length. That's still your width, or vice versa. So length is 4. Width is 4 because it's 4 by 4. Area equals 4 times 4 is 16. 16 is the area of one square. Now, a great thing about nets is you can technically write the answers inside each of them and then add them up. So it's a great visual in helping you. So these are all the same, 4 by 4. So that's going to be 16, 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 and that's going to be 16. So this is a good way to keep track that we have found the area of each and every surface. And then you can simply add them together. So we're just going to do repeated addition as multiplication. So 16 is the area of 1. We're going to multiply by 6 faces. We can do that because they're all equal. And we're going to get, I don't know because I don't know what 16 times 6 is. 96. And we're measuring in inches and its area, so squared. All right, let's write our answer. The surface area is 96 inches squared. So the nets are a good way so we can see all the surfaces so we don't leave one out. That's a very common mistake, leaving a side off. And it's a good way to keep track of what the area of all the faces are as well. Because again, the hardest part about finding surface area of an object is not finding the area of the individual pieces. It's leaving part of it out. Because if you just look at that, okay, I see the front, right, and top. You might forget the back or the bottom or the left side, or you might almost do all of them, just leave one out. All right, next example. We're going to move on to rectangular prisms. So we're just going to start with a couple examples of nets. So the first one resembles the net that we used for a cube. Nets can be in different arrangements. So these are two of the most popular arrangements for nets for rectangular prisms. It doesn't matter which one you use. Just ask yourself, which one do you think you're going to understand or remember the most? We are going to practice labeling length, width, and height of these nets, of these prisms. So the one that juts up is always going to be your length. And it's always going to alternate with length, width. Because this one's going to wrap down, even though this is not a rectangular prism net, I'm going to use it as my example. This one's going to come downwards, and this distance left to right is your length. This one wraps around, so that distance coming forward is going to be your width. This third one right here, well, technically it'd be like that. It's going to wrap around to the front, so it's going to be the length again, and then so on. So length, width, length, width. Here, the length is on that one. It's going to alternate width, length. That just means width is over there. Don't forget that these corners, they're going to snap shut. They have to be the same. So that's also going to be my width. And again, that's going to be my width. And then one more thing, height. The height is that distance between that top flap and that bottom flap. So those are all my heights. Now, do I need to label these bottom ones? Not necessarily, because they're going to be the same as those. We do have enough information, but just so you know, if that's my length, that's going to be the same, that's going to be the same, and that's going to be the same. And if that's my width, that one's going to be my width, and that's going to snap shut with this one. Same on this one. Now, what use is this? This is just a nice setup. So if you had a picture or information about a rectangular prism and it had some numbers, you would know where to put the numbers on this, because if you don't know where the numbers go, there's no point in finding the surface area. So I would know to replace all my L's, for example, with 4, if this was my example. All the W's would be replaced with 5s, and all the H's would be replaced with 3. And then I would simply find the area of a bunch of rectangles. Now, rectangles have a few shortcuts. They're not as easy as cubes because all the surfaces were identical squares on a cube. Well, with rectangular prisms, we have the characteristic that the top and bottom are identical, left and right are the same, and front and back are the same. So let's jot down that information. So if I were to look at this, this is going to fold down and be the top of my rectangular prism. This is going to be the bottom. Those two answers or areas should be the same. So we're going to keep in mind that the top is going to equal the bottom. So you don't need to find the area of the top and bottom. Just find the area of one of them. The other one will be the same. Next, this is going to be the back side. So I'm going to pull out my cube again. So that's my top. That's my bottom. So that one right there is in the back. So what would be the front? Well, it's this one on the very far right. It's going to wrap around and then be in the front. So those two are going to be the same. So the back is going to equal the front. And then last, that's going to wrap around to be my left side. And this is going to wrap around to be my right side. And those are also parallel and equal. So the left side is going to equal the right side. What does this mean? This means when you're finding the area of these individual faces, you just need to find the area of, for example, the top, the back, and the left, and the other three will be the same number. You don't need to find the area of them again. That would be, pointless. Okay, let's apply this to an example. So a rectangular prism is 12 inches by 8 inches by 4 inches. We're going to find the surface area of the rectangular prism. So let's think. If I had a rectangular prism, it could look like this, and no, it's not drawn to scale. So please, no judgment. Now, it's 12 by 8 by 4. What does that mean? When you see a setup like this typically means length by width by height. So if you see number by number by number, that means length by width by height. So length is 12, width is 8, and height is 4. So I need those numbers on here so I can find the area of all the surfaces so I don't forget any. So let's use our pattern. Length, width, length, width. They alternate. The one jutting up is always your length. Okay, next, height. Height is the distance between the top and bottom. So all the way across is going to be my heights. Let's replace them with numbers now. So my lengths are 12. So that's 12 all the way down. My widths are going to be 8. So that's 8. That's 8. Don't forget, these two have to be the same. It doesn't matter what it looks like because most likely you're going to be drawing these nets and they're not going to look perfect. So never base things off of looks. So that's going to be the width, and that's going to be 8. Oh, I forgot a length. That length is 12. All right, heights. The heights are 4. So that's 4, that's 4, that's 4, that's 4, that's 4. Pretty much have everything labeled except for this one. But again, I know that that's going to be the same as that. All right, now what do? Just find the area of a bunch of rectangles, essentially. So the hard part is knowing all of your parts and just getting the numbers on there so you can find the area. So where do we want to start? Let's just start on the left one. So this, again, would be the back. That's the top. This is not necessary. I'm just writing this down in case you are interested. So if that folds down, that's going to be the top of my rectangular prism. And that's going to be the right side. That's going to be the front. Just so you can kind of see how that would be that, or vice versa. Okay, let's find the area of the left rectangle first. So let's start with an area formula. A equals LW. Next, let's fill it in. A equals, it's 8 by 4. It doesn't matter which one's which. We're just going to say the length is 8 and the width is 4. Again, it's 8 by 4. A equals 8 times 4 is 32. So we found the area of the left rectangle. Are there any shortcuts? Yes, the left and right will be the same. So I'll just note that's 32 as well. All right, next, let's do the top rectangle, just because. So it's a rectangle, so A equals LW. A equals, what's my length and width of the top rectangle? It's 12 by 8. So 12 times 8. 12 times 8 is 96. So we found the area of the top rectangle to be 96. Shortcut, the bottom one's going to be the same as well. So I now have 1, 2, 3, 4 areas. I am missing the back and the front. So you can use this net also as a checklist. You can cross them out saying, oh, I found the left, let's cross it out, and so forth. That way you don't miss anything. Okay, I still need to do the back and front. Let's do the front. I have more room over here. So it's a rectangle, so A equals LW. A equals, what's my length and width? 12 and 4. Area equals, what's 12 times 4? 48. Okay, are there any shortcuts? Yes, the front and the back are the same. So I now have 1, 2, 3, 4, 5, 6 areas. What am I going to do with those? I'm going to go ahead and line them up just to make sure I don't leave any out. So I've got the top and bottom rectangle. The top and bottom are both 96. Then I have the left and right rectangle. They're both 32. And then I have the front and back rectangle. And they're both 48. And this is like a last minute check. Do I have 2 matching numbers for each? Top and bottom, left and right, and front and back. If I see a difference in there, it means I done messed up and I need to fix it. Okay, what am I going to do with these numbers? Add them. Surface area is the area of all surfaces, not just the top. So we're going to do 96 plus 96 plus 32 plus 32 plus 48 and 48. We get 352. All right, let's write our answer. The surface area is 352. We're measuring in inches and its area, so it's squared. 352 inches squared. All right, next example. We're going to move on to triangular prisms. So triangular prisms, there's not really a set pattern when creating your nets. I actually find them less annoying than the rectangular prisms and cubes. Okay, so I'm going to find the surface area of these two triangular prisms. First step is to draw a net. So I have already drawn them. These are pretty standard nets, consists of 3 rectangles and the 2 triangles stuck in the middle. You can put them in different locations, but this is pretty easy setup. So where should you start? There aren't lengths and widths or anything like that that I need to remember a pattern with. What you need to start with is the triangle. The triangle is the most identifying aspect of this whole thing. So I see these 2 triangles right here. So after you draw your net, 3 rectangles and 2 triangles, you're going to match up the triangles. And you're just going to transfer the numbers over. So let's look at this one and this one. I see that the base of the triangle is 6. Next, I see that this side of the triangle is 5. I see a dash mark right there. That means this side is equal to the opposite, so it's also 5. Not because it looks like it, because it has that little dash mark. We don't go on looks. We go based on facts. Next, I still need the height of a triangle. These aren't heights because they're slanted. Well, I don't see a height of a triangle. That's because I need to remember that this is a triangular prism, meaning the 2 triangles are my bases and they're equal and parallel to each other. So my height is back here, 4. They're trying to hide it from us. Rude. All right. So base is 6, height is 4. Those numbers are 5. Next, let's fill in our rectangles. So don't even look at your prism. Once you have the triangle, you can still fill out some more information without even needing to look at a picture or anything. So I've got an example of a net right here. Just like on the rectangular prisms and cubes, when you fold them together, those distances have to be equal. So what am I saying? I'm saying that if this side is 5, this rectangle, the top of it, also has to be 5 because they have to connect and they have to be the same distance. So that means this side is 5. And the same is true for the opposite side. When those connect and go all smushy smushy, that's going to be 5 as well. So now I have the length of that rectangle is 5. The length of this rectangle is 6 because it's attached to the triangle. The length of this rectangle is 5. So they're not all 3 the same size. What do I need? I need this distance, the width of the rectangle. So that's the distance between the 2 triangles. So let's look at my picture. Triangle in front, triangle in back. I want the distance between the 2 triangles. That would be 11. 11 is the distance between the 2 triangles. So 11, 11, 11, 11. Do I need to label this triangle? No, because they are your bases, they're going to be congruent. That means equal in size and shape. Okay, so I have everything labeled. What am I going to do? Well, I'm going to start finding the area of all of them. So first, let's find the area of this rectangle over here. Formula is A equals length times width. Next, A equals, my length and width are 5 and 11. So 5 times 11. So area equals 5 times 11 is 55. Okay, are any of the other rectangles the same? All of them, right? No. This one's 5 by 11. This one's 6 by 11, so it's not the same. This one, however, is 5 by 11 also. So I will go ahead and take a shortcut and say this one's 55 as well. So we already have 2 areas out of 1, 2, 3, 4, 5. Next, let's find the middle rectangle. So A equals length times width. A equals length and width are 6 and 11. So A equals 6 times 11 is 66. So I now have the 3 rectangles. I still need the 2 triangles. So let's find the area of this triangle right here. Triangle is A equals 1/2 times base times height. So A equals 1/2 times, what's the base of the triangle? 6. What's the height of the triangle? 4. All right, A equals 1/2 of 6 is 3, and I still need to multiply by 4. So A equals 12. If one triangle is 12, the other one is 12 as well. So now I have 1, 2, 3, 4, 5 areas. Let's add them up. Another strategy on being sure that you have all parts is following. So this has 2 triangles and 3 rectangles. So what am I going to do? I'm going to literally draw 2 little triangles and 3 rectangles. So my 2 triangle areas were 12 and 12. My 3 rectangles were not all the same, but they were 55, 66, and 55. And I messed up on that. 66, 55, and 55. So 2 55s and 66 in the middle. So this is just a double check of, okay, I know triangular prisms have 2 triangles and 3 rectangles. I have got my 5 numbers. And then what do? You add them. So we have 12 and 12, which is 24, plus 66, plus 2 55s. You get 200 even. All right, let's answer it. The surface area is 200, forgot my label, centimeters squared. All right, next example. So we have another triangular prism. First step would be to draw your net so you can see all the surfaces. I know they can seem annoying, but after over a decade of witnessing what students do, I've noticed that students are always more successful when they can see all the surfaces that they're finding the area of. It never fails. If they try to find the surface area of this without drawing a net, they're more likely going to fail because they will leave something out. Okay, so on triangular prisms, start by matching up the triangles. So you draw 3 rectangles, 2 triangles. You'll notice that I drew these triangles different. Why? I always try to make the triangles look like they do on the prism. So I see a right triangle, so I make a right triangle here. On this one, it looked like it was an isosceles triangle. Well, I knew because it had those dash marks. So I drew an isosceles triangle. Okay, back to this. We're going to match up these 2 triangles with our net. All right, so our height of our triangle is 12. Next, our base is 5. This distance right here, well, it's not in the front, but I see it in the back, 13. Okay, I have all the triangles labeled. Next, let's ignore the prism for now. Remember, these 2 are going to shut and close in on each other. So if this side's 13, that has to be 13. Same thing, those are going to close in and fold together. So if that side of the triangle is 12, this side of the rectangle has to be 12. Next, I need the distance between the 2 triangles. So now I'm going to look back at my prism. The distance between the 2 triangles is 9. All right, we have enough information. We can now go crazy and find all the areas. Okay, so first, what do we want to find the area of? Let's find the area of this rectangle right here. So A equals length times width. Also, one thing I haven't mentioned, if you draw your nets large enough, you could technically write the formulas inside of each shape and solve them inside. So it'd be like you're finding each piece of information inside of your picture. But I drew my nets small, so I don't have enough room to do that. All right, A equals my length and width are 12 and 9. All right, area equals 12 times 9 is 108. Okay, are any of the others the same? Well, let's see. This one's 12 by 9. This one's 5 by 9. This one's 13 by 9. That makes me very sad. I can't use any shortcuts. Okay, so let's find the area of this rectangle right here. So A equals length times width. A equals the length and width is 5 and 9. So 5 times 9, so area equals 45. Again, not the same. Very sad. Okay. Area equals length times width. Area equals 13 by 9. So area equals 13 times 9 is 117. Last, the triangles. At least the triangles are identical. That way, I only have to find one of them. Okay, I think we have enough room right here. So A equals 1/2 times base times height. So A equals 1/2 times the base is 5. The height is 12. Look for those right angles. So A equals half of 5 is 2.5. And I still need to multiply by 12. So area equals 2.5 times 12. I really don't need a calculator for that, but whatever. 30. Okay, and the other triangle is going to be 30 as well. All right, let's list them all and make sure I have them all. So I have got 2 triangles, and each of them were 30. Then I have 3 all different rectangles. The rectangles were 108, 45, and then 117. Fun fact, the size of your rectangles depends on the dimensions of your triangle. So notice, a scaling triangle, all 3 different sizes, 3 different rectangles. Isosceles triangle, that means 2 sides are the same. Guess what? 2 of the rectangles are identical. The third one is not. So your rectangles sizes will depend on the size or type of triangle they surround. So that means the best and easiest one would be an equilateral triangle. So if you have an equilateral triangle, all 3 rectangles are going to be the same size. How nice is that? Too bad we didn't have one of those. Okay, so back to this. We're going to add 30 and 30, which is 60, plus 108, plus 45, plus 117. So 30 and 30, and then 108, and 45, and 117. We get 330. All right, let's answer this. The surface area is 330 centimeters squared. We have 2 more examples. All right, good thing, because we're already at 39 minutes. Okay, we're going to find the area, surface area of the following prism. You guessed it, another triangular prism. These things just pop up like daisies. All right, first step, you draw a net. So sad we don't already have one for you. So we're going to use a standard, 3 rectangles. I don't care what they look like. I'm not even trying to make them different. It doesn't matter. Just draw 3 rectangles and 2 triangles. The triangles I will try to match. This one is 5, that side's 5, and that side is 5. So it looks like an equilateral triangle. So I'm going to try to draw an equilateral triangle. That kind of stinks, but I tried. Okay, that's the only thing I really try on, making the triangles look like what they do in the picture. Okay, let's label. So we're going to focus on the triangles and transfer our information. So this side's 5, the right side's 5. The bottom side doesn't have a number. So I look at the other triangle and I see that it's also 5. It's an equilateral triangle. Next, what's the height of the triangle? It is 6. Next, these rectangles. So those two pieces are going to close in. So that means this side has to be 5. And that side has to be 5 because that's going to close in. Notice all rectangles, 5, 5, and 5. All right, what's the distance between the two triangles? 7.5. All right, what do we want to find first? Let's find the area of the rectangle. Guess what? I drew this kind of big, so let's try writing the formulas inside. So area equals length times width. Area equals 5 times 7.5. So area equals 5 times 7.5 is 37.5. Are the others the same? Yes, 5 by 7.5, 5 by 7.5, 5 by 7.5. So I'm just going to fill in 37.5, 37.5. All three rectangles are the same. Because I've done this, I know I need just the two triangles. So let's find the area of this triangle. That's unfortunately not big enough to write the formula in. Area equals 1/2 times base times height. So area equals 1/2 times the base is 5, height is 6. So area equals 1/2 of 5 is 2.5 and multiply by 6. So area equals 2.5 times 6. I really shouldn't be using a calculator for that. You get 15. The other triangle will be 15 as well. All right, let's add them up. So I've got 2 triangles and 3 rectangles. The 2 triangles were 15 each, and the 3 rectangles are all the same, 37.5. All right, let's add that up. So 37.5 times 3, because there's 3 of them, and add 15 and 15, which is 30. I get 142.5. All right, let's answer this. The surface area is 142 and 5/10 inches squared. Last example. The pyramid below, technically it's a net of a pyramid, has a square base measuring 10 inches. It has 4 faces that are congruent isosceles triangles. Congruent means equal. So it just said that all 4 triangles are equal. The height of each triangle is 12 inches. Find the surface area. So we would draw a net. It's a square pyramid, so that means 1 square and 4 triangles. It said the sides of the square are 10. Next, it said the height of each triangle is 12. So, do we have enough information? Yes. We have base and height of a triangle, and we have length and width of the square. All right, let's do the square first. Area equals length times width. Area equals 10 times 10. Area equals 100. Next, let's do the triangle. Area equals 1/2 times base times height. Area equals 1/2 times the base is 10. The height is 12. So area equals 1/2 of 10 is 5 times 12. Then area equals 5 times 12 is 60. And guess what? They're all congruent isosceles triangles. So this one is 60. This one is 60. Everyone gets a 60, the triangles that is. Okay, so we have 3 triangles that are all, actually, sorry, 4 triangles, because it's a square pyramid. It's got 4 triangle faces that are all 60. And a square bottom, which is 100. So let's add those together. 60, 120, 180, 240 plus 100 is 340. Let's answer it. The surface area is 340 inches squared. I hope this has helped with finding surface area of different geometric solids. If it has not, I hope you can find what you're looking for elsewhere. Y'all have a great day.